Welcome back, everyone. This is the Delta Workbook. It's Mr. Australia here, and we're on lesson 4. Today we're working out the original quantity before a percentage increase or decrease. This is also known as reverse percentages. If you haven't done so already, pause the video and have a go at the do it now questions. Okay, first, this time we've got a few different things going on in this calculation. We've got 45 multiplied by 0.2, add 2.5. To work out or to know which part of this we need to perform first, we think about our order of operations. And the word that we use to help us remember that is BIDMAS or BODMAS, starting at the B, ending at the S. Now, here we've got multiplication, M, and addition, A. The M comes first in BIDMAS or BODMAS, so you must do that first. 45 multiplied by 2, okay, 45 multiplied by 2, I've taken out 2 decimal places there. If 45 multiplied by 2 gives me 90, then 4.5 multiplied by 0.2 will give me 0.90 or 0.9. So the first part of that is actually just going to be 0.9. Now we're ready to add 2.5. Okay, so there you're going to get 3.4. Okay, next, number 2. We've been asked to complete the ratio, 1 to 6. And that ratio is equivalent to something to 150. So you can think about this in a similar way to our equivalent fractions when we're trying to find equivalent fractions. It's like we had a fraction that started off as something over 150, and we've simplified it, and it's then gone to 1 over 6. So what I need to do is have a think. How have I got from 150 to 6? Okay, or how many lots of 6 can fit inside 150? To find that out, I'm going to use the bus stop method here. Okay, how many 6s fit into 1? None. How many 6s fit into 15? 2. That got us to 12, so we have a remainder of 3. How many 6s fit into 30? 5. Okay, so we've got 25 lots of 6 in 150. So if we've got from 6 to 150, I'm just going to write it out like this. 1/6 to something over 150. From 6 to 150, we've multiplied by 25. So to keep it equivalent, we must do the same to the top as well. 1 multiplied by 25 gives you 25. Okay, so the answer here is going to be equivalent to 25 to 150. Okay, next we've been asked to solve this equation. There's quite a few steps in this equation. So I'm going to do my working out. I'm just going to move over a little bit and do my working out here just so we've got plenty of space. Okay, so I'm going to start by writing out the equation again. 4 plus 3 lots of brackets x minus 2, close brackets, and that's all equal to 2x plus 4. Okay, so again, thinking back to your order of operations, B is at the start for BIDMAS and BODMAS, so you must do your brackets first. Now, x minus 2, we cannot do anything there because we don't know what x is yet. So we go to the next letter in our BIDMAS, our indices. We don't have any of those or our operations. Finally, we have our division. No, we've got multiplication here. We've got 3 multiplied by everything inside those brackets. So we're going to expand those out. Haven't done anything with the 4. Now, 3 multiplied by x gives me 3x. But positive 3 multiplied by negative 2 gives me negative 6. And then I haven't done anything with my 2x plus 4 either. Okay, this is looking a bit better. When you've got x's on both sides of the equal sign, what you want to do is you want to change that. You want your unknown terms, your x's, on one side of the equals, and you want your numbers, your values, on the other side of the equal sign, because you're trying to get a term equal to a value, a number. So I'm going to get rid of my smallest x first. Okay, so I'm going to subtract 2x from both sides. Still going to leave my 4 the same. Now I'm subtracting 2x, so 3x subtract 2x leaves me with 1x, and then we've got this negative 6. And then I took 2x away, so we're going to have nothing there but our positive 4. You don't have to write that plus sign, it's just positive 4. Okay? So that is all equal to 4. Now I need to simplify this a bit. Here I've got 4 and a negative 6, so positive 4 and negative 6, you combine those, you're left with negative 2. Then we've got our positive x, and that's all equal to 4. I now want x equals a number, so I need to get rid of this negative 2. When I say get rid, I mean turn to 0. How do you get from negative 2 to 0? You add 2. So I've added 2 to this side, and I need to keep my equation balanced and add 2 to this side. So our final answer there, x is equal to 6. Okay, x is equal to 6. I'll just write this out. Final answer there, x was equal to 6. Okay. Right, next, number 4, we've been asked, does the point 2-4 lie on the line y equals 5x minus 6? Well, for our coordinates, we always need to think about our coordinates in terms of x and y. They will always be written in this order. Therefore, the coordinates that we have here, you can think about them as having an x value, that's your x coordinate 2, and your y coordinate was 4. Now, when we're asked for the gradient or the y-intercept to the line, we need to think about the general equation of any straight line. It will be in this format, y equals mx plus c. Your plus c, that's your y-intercept, where it crosses through the y-axis. The m value, the number in front of the x, will be its gradient, okay? Now, if we've got an equation in the format y equals mx plus c, and we've got an x value of 2 and a y value of 4, this equation should hold true. What do I mean by that? Well, if you think about this, 2 plus 2, that's equal to 4. If you simplify the left-hand side of this equation, 2 plus 2, that is equal to 4, and 4 is equal to 4. That makes sense. So here, this equation holds true. That is what we want. That equal sign literally means is equal to or the same as. So we want to substitute these values in. X was 2, y was 4. So I'm going to write that out now. Y was 4. Okay. We had a 5, that was our m value, so we had 5x. Our x value, so I'll just put that in brackets because we've substituted it. Our x value was 2. And then our plus c term was negative 6. Okay, I've got all of that from this. Just rewritten that. Our x value, 2, was here. And as you can see, our y value was 4. Here. Okay. I now need to just simplify that. Here I've just got a 4 still. I haven't done anything with that. When you've got a term next to a term inside a bracket, that means you're multiplying. So 5 multiplied by 2 gives me 10. And then I've got my negative 6. If I simplify that a bit more, then I've got 4 equals 4. 4 is the same as 4. That makes sense. We've got one side of the equal sign equaling the other. So therefore, this point does lie on this line. So your final answer would be yes, but you must have included this working out to get full marks for that question. Okay, so you've got to show your working out. You want to write out y equals mx plus c. You want to write out the equation you've got, and then substitute your x and y values in from the coordinate. Solve your equation. If one side is equal to the other side, then the point does lie on the line. If they are not equal, for example, if you got something like this, 3 equals 4, that doesn't make sense, so no, it would not be on the line. But here we had 4 was equal to 4, yes, that makes sense, so the point is on the line. Okay, number 5, find the nth term. So let's write that out. 5, 16, 27, 38. Hey, what's going on here? What's going on here? Well, what are we doing each time? Here we're adding 11. Because we're adding 11 each time, that means that we found the first bit of our nth term, it's 11n. And we've got a form of the 11 times table here. So I'm just going to write that beneath. Now, how do we get from the 11 times table to the actual terms in our sequence? How do you get from 11 to 5? You subtract 6. Does that work from 22 to 16? Yes, it does. It works for all of the terms we've got in our sequence. So we found the final part of our nth term, 11n, subtract 6. Okay, question 6, we've been asked about the gradient. Whenever you've been given a question about a straight line graph, it's never a bad idea just to write down that y equals mx plus c. Because whenever you're trying to interpret or get some information about an equation of a line, this is the format you want it in to be able to do so. So the first thing I'm going to do is just write out the equation that I was given, 3x plus y equals 4, and try and rearrange that into the format y equals mx plus c. So I want to start with y. So I'm going to leave my y, okay, on that side of the equal sign. And I need to now get rid of this 3x. I get rid of 3x by subtracting 3x from both sides. And then I've got my 4. It's a 4 on its own. That means it's a positive 4. It doesn't have a minus sign anywhere near it. If you've just got a number on its own, you can assume that number is positive. I've now got it in the correct format. Now let's have a think. Our gradient, that was the m value, the number in front of your x. My m value here is negative 3. So that means my gradient is negative 3. Okay, the sign is attached to the number there. If it asked you what your y-intercept was, then your y-intercept would be whatever was in the position of C. So your y-intercept would be positive 4. Right, let's have a look at the examples here. So I said earlier that today we're actually going to be doing the reverse of what we were doing last lesson. Today we're going to be given some amounts that have been either increased or decreased by a percentage, and we are trying to work backwards. We're trying to find what the original amount was. There are two different methods, well, there are many different methods for doing this. I'm going to show you two today. One is a method that you can use without a calculator for more simple questions, and another method is for any calculation that you wanted to do and that you're allowed to use a calculator for. Okay, so first we're going to have a look at the non-calculator method. And this method is very, very similar to what we saw yesterday, but just in reverse. So let's imagine you were told that you had a 50% increase of an object. So this is our non-calc. So you had a 50% increase of an object, and that object's new cost was £300. So after a 50% increase, that was £300. You think about your original amount as being 100%, and you've increased it by 50%, then the amount that you have, this £300, is going to be equivalent to 150%. Okay? And what we're trying to get back to is our original. And as we know, the original is always equal to 100%. So now I've got to manipulate this 150 and try and get to 100. Now, I know 150, that's in the 5 times table. So is 10, so is 100. It's also in the 50 times table. So what I'm going to do here is I'm going to divide this by 3. 150 divided by 3 leaves me with 50%. So I know it's very easy to get from 50% to 100%. If I divided that by 3, I'd need to do the same thing with my amount and divide that by 3. So 50% is equal to 100. I now need to get from 50% back to the original amount. From 50 to 100, you multiply by 2. So I'm going to do the same with my amount and multiply that by 2. 100 multiplied by 2 gives you 200. Okay, so that was our non-calculator method. And the key thing there is you want to get back to your original amount, your 100%. So you work out the percentage that you've been given. If it was a 50% increase, then you'd add 50 to 100%. If it was a 50% decrease, then you'd have 100% minus 50%, which would leave you with just 50%. Okay, so got to pay attention to the wording there, whether it's increase or decrease. I'm now going to show you a method that we could use with a calculator, and that's the method that they've got here in example 1. Now, if you're allowed to use a calculator, the best approach to take is to find out what 1% is. In the example there, they picked 112%, okay? And they've gone from 112% to 1% by dividing by 112. They've kept their equation valid, and they've divided the amount by 112 as well. That means they've got 1%. Now, from 1%, whenever you've got 1%, it's very, very easy to get to 100%. You just multiply by 100, and that placeholder will move 2 times. So they've now multiplied 1% by 100 to get back to the original 100%. And then to keep their equation valid and equivalent, they've multiplied the amount by 100% as well. Okay, so key thing there, if you've got a calculator, you go from whatever percentage you were given to 1% by dividing by that amount. So say 73%, you divide by 73, 19%, you divide by 19, 251%, you divide by 251. Then whenever you've got 1% to get to 100%, nice and easy, you just multiply by 100. Okay, then let's put that to test. Let's have a go at some of these questions here. Right, question number 1. This is too large. So a fridge costs £200, but it costs £200 after a 50% reduction. After a 50% reduction. So let's do this one here. Now, this would be a non-calculator question. We've got very nice amounts and there wouldn't be too complex calculations. So let's have a go at that. A fridge costs £200 after 50% reduction. If you've reduced something by 50%, that means that you've now got 50%, because 100 take away 50 leaves you with 50. So this £200 is 50%. Now, we want to find the original. The original will always be 100%. How do we get from 50 to 100? Multiplied by 2. So you'll need to do the same thing with your amount and multiply that by 2 as well. Therefore, the original price of our TV was £400, remembering to include those units. Okay, next, question 2. Andy buys a top hat. I'll just highlight that to show that we've done it. So we've done 1. We're now on question number 2. Okay, Andy buys a top hat that's been reduced in sale by 35%. Okay, so if you think about your original starting at 100% and you've reduced it by 35%, then you've taken 35% as well away. So that will leave you with 65%. So the amount that you've got here for your top hat, your sale price, that is equivalent to 65%. And we bought that for £13. Okay. What I now need to get back to is 100%. And I can do that by using 5%. How do I get from 65 to 5? I've divided by 13. From 65 to 5, I've divided by 13. So I'll need to do the same with my amount here and divide that by 13. £13 divided by 13 leaves you with £1. I now need to get back to 100%. How do you get from 5% to 10%? Sorry, to 100%? Well, 5 times 2 gives you 100%. So 5 times 20 will give you the 100% that you're after. So now we're multiplying £1 by 20, and that will give you £20. Okay, so that one there, question number 2, £20. That was your original price. Okay then, let's have a look at number 3 now. So number 3, the owner of a furniture shop increased the price of a bookcase by 26%. So if we've increased the price, that means we've got over than 100%. So what I'm going to do for number 3, up here, we've increased by 26%. That means that our new amount will be equivalent to 126%. Okay, and that was priced at 819. And what we're trying to get down to, remember, is 100%. That's what we're trying to get to. This is a very awkward amount, 126%, to find 100% without a calculator. So what we want to do here is go from 126% to 1%. How would we do that? We would divide by 126. And you need to divide your amount by 126 as well. Okay, once you've done that, you'd get the 1% is equivalent to £6.50. Then how are you going to get from 1% back to the original 100%? You just multiply by 100. So it's going to be the same thing here. Multiply that by 100. Okay. So our original amount there for the percentage increase was £650. Okay. Right, number 4. This time an estate agent has reduced the price of a house by 4%. So if you're reducing, you would have started with 100%. And then if you've reduced it by 4%, you're taking 4% away. Okay, so this is question number 4. This time we've started with 100% and we've taken away 4%. So that will leave us with 96%. Okay, so the new price of the house, that's equivalent to 96% of the original. 192,000. And again, we're trying to get back to 100%. Now, this one here, it may look like quite a tricky one, but actually here, how do we get from 96 to 1%? We divide by 96. How many lots of 96 have you got in 192? You've got 2. So how many in 192,000? You've got 2,000, comma, 1,000. So there we divided by 96. And then from 1% to 100%, again, just multiply by 100. So the original price of our house was £200,000. Must include those units, £200,000. Okay then, that was question number 4. Oh, I've been highlighting. So we've now done all of these questions. We're just going to have a look now at question 5 and then move on to question 6. Okay, so question 5. A group of people sit their driving test and 24 people passed. They've also told us that 80% of the people passed the driving test. So we've got 24 people passed and 80% of people passed. So straight away we know that 80% is equivalent to 24 people. Trying to get back to 100. Okay, you now need to work this 80%, do a couple of steps and try and get to 100% using multiplication and division. First thing I'm going to do here is I'm going to go from 80% to, let's have a think, 10%. Because here you're just dividing by 8 and I can see that 24 is a member of the 8 times table as well. So that's going to give me no remainders. It's going to be a nice whole number. Okay, divided those both by 8. From 10 to 100, nice and simple. We just multiply by 10. Okay, so that's 30. How many people sat the test together? It's going to be 30. Okay, number 5. Just scroll down a bit so we've got a bit more space. Okay, that was number 5. Now having a look at question number 6. Okay, number 6, we'll do that over here. So an energy bar contains 2.1 grams of protein, and 6% of that bar is protein, okay? So 6% is equivalent to 2.1 grams. We want the total mass of the bar, so again, we're trying to get to 100%. Okay, from 6 to 1%, that's what we're going to do this time. We're dividing by 6. Okay, so if you're trying to do 2.1 divided by 6, have a think about 21 divided by 6. What would that give you? So 6, we're going 9, 21, that would go 3. And our remainder here would be 3 again, and that would go 5. But our original was not 21 divided by 6, it was 2.1 divided by 6. So that's not going to be 3.5, it will be 0.35 grams. You could have also done that, by doing 21 divided by 60, and you would have got the same thing here, 0.35 grams. Then from 1% to 100%, we just multiplying by 100. So we do the same thing there. The placeholder will move twice, and our final answer is going to be 35 grams. Okay, and that was it for this lesson. The Hecate tasks related to this lesson are, task 96, those reverse percentages. And the core bit activities are really, really good for this, particularly at the end of the textbook exercise, the apply section. It gives you lots of real world applications of this skill. Anyone who goes into any type of banking, investment, stock exchanges, this calculation will be performed all of the time. So it's a really, really useful thing for you guys to be comfortable with. It'll open up a lot of opportunities for you later on in mathematics, and also when you guys go into the world of work. Thanks again for today, and I'll see you in our next lesson.